All right, I'm going to go ahead and go through this review kind of problem by problem. I'm going to try to keep the videos about 20 minutes, but we'll see if I can get through this or not. So this is what we have for the first problem. It says, what is the product of 5 square root of 5 and 5 square root of 15 in simplest radical form? So we're going to go ahead and multiply these 5 square root of 5 times 5 square root of 15. And what we do is we multiply the numbers on the outside times the numbers on the inside and throw them back underneath the square root. So 5 times 15 is equal to 75. And then if I can simplify this radical, I will. So I have 25. And then this simplifies the square root of 25 times the square root of 3, which is 25 times 5 square root of 3. And 25 times 5 is 125 square root of 3. So this will simplify to 125 square root 3. Next problem. So we're going to simplify, or we're going to divide here. So in dividing, I have square root of 40 over square root of 2. And because they're both underneath the radical, I can just go ahead and divide. And that gives me the square root of 20. And I'm looking for a perfect square factor, which would be square root of 4 square root of 5, which is 2 square root of 5. Again, as I'm doing these, it's important to remember, like, how come I don't write square root of 2 and square root of 10? 2 times 10 is 20, but neither of those are perfect squares that I can simplify. So the answer is just 2 square root 5. As I'm going through this, or maybe times I accidentally hit the wrong button or something like that, it just is what it is. We'll go through and talk about the mistake if I make one. 6 over square root of 10. So this is rationalizing the denominator. We're going to multiply top and bottom by the denominator. So it's going to give me 6 square root of 10 all over. Square root of 10 times the square root of 10 is just 10. No more square root. And then if I can simplify this, I'm going to, and I can. This 6 and 10 are both outside of the radical, so this just becomes a 3 square root 10 all over 5. So when I write this out, 3 square root 10, square root of 10, square root 10, and that's all divided by 5. And there's nothing else that can be simplified there. So the next problem, we have solve the following quadratic equation for all values. Okay, so this is using square roots. So for using square roots, I have 11 minus x squared equals 7. So I'm going to get this x squared by itself. So I'm going to subtract 11. Negative x squared equals negative 4. Divide by negative 1. And I get x squared is equal to 4. I'm going to square root both sides, and x is going to equal plus or minus 2. Again, when you take the square root of both sides, your answer becomes plus or minus. Okay, so again, solving by taking square roots. So in this one, we have to get what's being squared by itself. So I have 2x minus 7 squared minus 37 is equal to negative 35. So I'm going to add 37 first. That's going to give me 2 outside of x minus 7 squared is equal to 2. Divide by 2. It gives me x minus 7 squared equals 1. Now, at this point, I'm going to square root both sides. That's going to give me x minus 7 equals plus or minus the square root of 1 is 1. So no more radical there. What does that really mean? It means x minus 7 equals 1, and x minus 7 equals negative 1. I'm going to add 7. X equals 8. I'm going to add 7. X is equal to, sorry, I'm getting a little sloppy here. I'm going kind of quick. X equals 6. So I'm going to submit my answer here of 8 and 6. I'm going to put 8. I'm going to add another box and put 6. So next section, solving with square roots again. Problem's going to get a little bit more challenging as we go through these. 2x squared plus 3 equals negative 61. I'll subtract the 3. 2x squared equals negative 64. I'm going to divide by 2. And 2x squared is going to equal negative 32. I'm sorry, no, just x squared. Okay, no 2 there. So Now, at this point, I'm going to take the square root of both sides. Okay, so I'm going to square root. My answer is going to become plus or minus. Okay, so x equals plus or minus. And I have to simplify this. So what does this simplify to? Square root of -1, square root of 16, square root of 2. If I multiply -1 times 16 times 2, it's going to give me -32, and I can simplify both of these to 4i square root 2. So I go over here, I'm going to click plus or minus, I'm going to put 4i square root 2. Okay. So this one, simplify the square root of -250. Again, we always want to find the largest perfect square factor of these values. So -250, I know I'm going to make it a -1. I'm thinking square root of -1, square root of 25, and square root of 10, right? So that would be 5i square root 10. And I know I can write square root of 10 as 2 and 5, but neither of those are perfect squares. So 5i square root 10 is the simplified answer. Next problem here, add, subtract complex numbers. I'm literally just combining like terms. So I'm going to put 9 plus -2, which is 7, and -2i plus -5i, which is a -7i. Add, subtract complex numbers. So here I'm subtracting. I'm going to go ahead and write this down. I know you can use a calculator here. 11 plus 8i. I'm going to change this minus to a plus. And when I do that, all these signs change. So it'll be plus 5 minus 4i. 11 plus 5 is 16. 8i minus 4i is plus 4i. Again, make sure your signs are right. 11 minus a minus is 16. 8 minus a 4 is 4. Submit your answer. There's the answer for that one. Okay. Now we're going to multiply. So in this one, and again, I highly encourage you, use your calculator. I'm not going to. I'm going to show you how to do it. I already showed you how to use a calculator, so we're going to FOIL this. That gives me a positive 88 minus 110i minus a 72i, and then plus a 90i squared. So I've got 88. This right here gives me a minus 182i, and this is going to turn to a minus 90 because I squared equals -1. So when I combine these, it's just -2 minus 182i. -2 minus 182i. Make sure. And again, I would check all these in the calculator before I submitted them just to make sure I didn't screw up a sign somewhere. And I'm going to go ahead and use the calculator for this one because dividing can be very challenging. So I'm going to go -24 in parentheses, -24 minus 28i divided by 10 plus 6i. Hit equals, and it's a -3 minus I. -3 minus I. Next section, finding the discriminant. So for this problem, we need to make sure that it's set equal to 0 before I can find the discriminant. So I'm going to take this quadratic 3x squared plus 48x plus 199 equals 7. I'm going to subtract 7. So 3x squared plus 48x plus 192 equals 0. So now I can plug it into the formula b squared. That's a terrible b, sorry. B squared minus 4ac. And I'm going to get 48 squared minus 4 times a times c. So plug that into the calculator. Okay, 48 squared. 48 squared minus 4 times 3 times 192, and that equals 0. Okay, so I get 0. So the discriminant, the value of the discriminant is 0. That means there is one real solution and 0 imaginary. If you have any real solutions, then that means that there are never any imaginary. Same thing, if you have imaginary, then you don't have any real solutions. Okay, solve the equation of the nearest tenth. So here's where we're going to do the quadratic formula. And we're going to make sure that we plug this in correct. It's already set equal to 0. So x squared minus 6x minus 41 equals 0. So I'd have the opposite of b, which is 6, plus or minus the square root of b squared minus 4 times a times c. That's a terrible. I want to make sure you can read this. 41 all over 2 times a. So I've got 6 plus or minus a blank square root. Again, I get the calculator out. I put in negative 6 squared minus 4 times 1 times negative 41. And I get 200 all over 2. And I'm going to simplify this. So they want the nearest tenth. So I'm going to go ahead and get a decimal. So the square root of 200 is 14.14. So I've got 6 plus 14.1421356.2. Super important that you do not round too early. But again, as you're doing this, you can just leave it in the calculator, divided by 2, and I get an answer of 10.1 for one of my answers. And I get an answer of, sorry, get rid of that. I get an answer of 10.1 is one of my answers, and then I'm going to get my other answer would be 6 minus 14. 6 minus 14.1421356.2 all over 2. So 6 minus 14.14212135 divided by 2, and I get a negative 4.1. And again, we're rounding to the nearest tenths place. Make sure you pay attention to that. Again, I'm going through this kind of quick, so let's make sure these answers are right. If they're not, I'll show the work, but it is right. Make sure you're entering the calculator correctly as you do these. So greatest common factor. So for this problem right here, and again, I want to make sure that we go through this stuff and you're understanding it. 8x minus 3x squared. The numbers don't have a common factor. I just have an x I can take out. So it'd be 8 minus a 3x. So pretty simple, writing this stuff out when you're factoring. Hopefully you know how to factor or remember or learned it. I could take a number out. Like if this was a 2, I would have taken a 2 out. And you can always go back and multiply it through to see. So here, a negative 27 x minus 30 x to the fourth. So like these two, first of all, if the first number is negative, I want to take a negative out. And because they're both divisible by 3, I'm going to take out a 3, and I can take out an x. So I'm really dividing each of these by 3x. And that would give me a 9 plus, the signs change because I'm taking out a negative, plus a 10x to the third. Okay, and I'm not sure how Delta Math is going to mark this. I'm not sure if you need to put them in standard form. I wouldn't think so, but 9 plus 10x to the third. And again, you hit that little caret button, which is shift 6 to get the third there. So you can write your answer. Okay, factor the expression completely. So I've got y cubed minus xy cubed. I'm going to take a y cubed out. That's going to leave me with a 1 minus x. It's important when you divide something by the whole entire GCF that you get a 1. You're dividing here. So again, I'd have a y cubed parentheses 1 minus x. All right, so factoring trinomial, so I'm looking for two numbers that multiply to 9 and add to 10. So it would be x plus 9, x plus 1. And again, the order doesn't matter. Okay, x plus 9, because when I multiply this, x squared plus 9x plus 1x gives me my 10x, and 9 times 1 gives me my 9. Okay, here, factor the trinomial. So here, again, as you're doing this, and I believe we did the x method, I prefer the guess and check, where I need two numbers that multiply to 3x squared. I know it's 3x and x, and now I need two numbers that multiply to 25, which are 5 and 5. And then I just check. When I FOIL this out, this would be 15x and this would be 5x, and 15x plus 5x is my middle term that I need. So it's a little bit easier. Those of you that understand the math and your numbers really well, you see, man, that's pretty simple. If not, then you're doing the x method and you're factoring it that way like I taught you in the notes. Okay, same exact thing here. I've got, not that. I've got a 3x squared minus 2x minus 5, and I know that it has to be a 3x and an x. And now I got to multiply it so it's negative 5. And when I plug it in, it's got to add to a negative 2. Okay, so the only numbers I know of are 5 and 2, or 5 and 1, I mean. So minus 5 plus 1, right? Negative 5 times 1 is negative 5. My outer and my inner would give me a 3x minus 5x, which gives me my middle term. So once you get better at factoring and practicing this, they go a little bit quicker. 3x minus 5. Again, if you don't know what I just did there, then go back and look at the notes from 4.4, day 2, and you should be factoring these using the x method that I taught you. Okay, multi-step factoring. So we're going to take a GCF out first on this problem. So negative 5x cubed minus 30x squared plus 200x. I'm going to take an x out and a negative 5. So really, I'm dividing all these by negative 5x, which would give me x squared. Negative 5x, which would give me a plus 6x. Negative 5x, which would give me a minus 200 divided by 5 is 40. And then now I'm going to find two numbers that multiply to negative 40 and add to positive 6. So that would be an x plus 10, x minus 4. So again, when I put this in there, negative 5x plus 10, x minus 4. And you can't put x minus 10, x plus 4, because that would give you the wrong thing there. But you can, it doesn't matter if you put the x minus 4 first or the x plus 10 first when you do this. It should give you the correct answer, and it does. Okay, so now write a quadratic below in standard form. So what they're asking you to do is to FOIL this and then write it in standard form. So you would have, I'm going to FOIL this before I distribute. So x squared plus 8x plus 2x plus 16, 4 times x squared plus 10x plus 16. And then I distribute this, 4x squared plus 40x plus 16 times 4 is 64. 64, and that's what I get as my standard form here. Okay, 4x squared. And hit the caret button to get the squared. Plus 40x plus 64. Next problem, solve for all values of x by factoring. So I want you to factor this. This is the difference of two perfect squares. So x squared minus 1 would be x plus 1, x minus 1. So I set each of these equal to 0, and I solve. So I get minus 1, minus 1. I get x equals negative 1. Add 1, I get x equals positive 1. And again, I'm solving this, so I get 1, add it, I get negative 1. And this is where the graph would cross the x-axis if I went ahead and graphed this. All right, solve the following quadratic by factoring, which means I need to set it equal to 0 first and then use the 0 product property. So I have x squared plus 6x equals x plus 50. I subtract x, I subtract 50. So I've got x squared plus 5x minus 50 equals 0. So now I'm going to factor this. Two numbers that multiply to negative 50 and add to 5 are a plus 10, x minus 5. And then the zero product property is just the opposite of these. So again, you can set them equal to 0 and solve it. But for the sake of time, I'm going to just tell you it's the opposite. Again, this is stuff from 4.4 that we did last week. So hopefully you remember some of that stuff. If not, go back and look at those notes. 6x squared minus 4x plus 1 is equal to negative 9x plus 5. Set it equal to 0. So I've got a 6x squared plus 5x minus 4 equals 0. So here, I've got a decision here when I do my guess and check. I can have a 6x and an x, and I can have a 3x and a 2x. And I've got to, when I do this, put whatever two numbers multiply to negative 4, okay, which would be 1 and 4 or 2 and 2, and it's got to add to 5 in the middle here. So I've got a decision. I could either put a 2 and a 2 here, or I could put a 2 and a 2 here. And if I put a plus 2 here and a minus 2 here, that doesn't work. Okay, but I could do a 4 and a 1, like here. If I do a plus 4 here and a minus 1 here, when I do my outside, it gives me a minus 3. My inside gives me a plus 8, and that would add to my plus 4. So now I'm going to go ahead and do set them equal to 0 and solve. So 3x plus 4 equals 0, subtract 4. 3x equals negative 4, divide by 3. I get x is equal to a negative 4 over 3. This one, 2x minus 1 equals 0. I add 1. 2x equals 1. I divide by 2. I'm running out of room here, and x equals a positive 1/2. Okay, so ran out of room, 1/2. So my two answers are negative 4 over 3 and positive 1/2. Word problems: the length of a rectangle is 2 units more than the width. The area of the rectangle is 64 units. What is the width in units of the rectangle? I'm going to stop this video and do this problem on the next video. This is getting too long. I want to make sure it will upload.